Hello, this is Peter Ashley with HUD's Office of Lead Hazard Control and Healthy Homes. And I'd like to welcome you to the third in our series of 6 Healthy Homes seminars for this fiscal year. Today, we're going to be talking about childhood lead exposure, some of the impact of lead exposure, and importantly, maybe more importantly, what can be done to prevent lead exposure, and what can be done once a child is exposed to lead to mitigate the effects. We have very experienced speakers with us today, many years of work in this field, and we really appreciate their time and effort to be here with us. I wanted to recognize Lisa Christ from EPA's Office of Groundwater and Drinking Water, who joined our panel today, kind of a last minute. We thought that because of the attention that lead in drinking water has gotten with the Flint situation, that it would be important to hear about what EPA is doing in this area. So before we get started, I just wanted to go over a little bit of background on this topic. The slide in front of you summarizes some data from our 2006 American Healthy Home Survey, and it just illustrates the extent of homes in the U.S. That have lead-based paint. So that's 37 million as of 2006. This number decreases over time with demolition and gut rehab, but it's still a very large number. Number of homes with at least one lead-based paint hazard is about 23 million. So a hazard could be peeling or chipping lead-based paint, high levels of lead in soil, or high levels of lead in dust. This table also indicates really the audience that is the biggest concern for lead exposure. That's children under the age of 6. And this survey gave us this estimate of 3.6 million homes with one or more lead hazards and a child under 6. And the lowest row is the target audience of our lead program here at HUD. It's households with young children that are low income. So that's at about 1 million. Next, please. This slide is just a brief overview of HUD's lead hazard control program. We've been in existence since 1993. We give grants to local government and state government to address lead-based paint hazards in low-income housing. We've, over the years, given out, I think, over $1.5 billion in funds. They support not just direct intervention, but education and outreach, and the development of the industry, trained risk assessors and inspectors as well. So combined with our enforcement of lead regulations, we estimate that we've made over the years about 420,000 housing units in the U.S. lead safe. Current awards to our grantees who are in the field now are about a little over 400 million. But we've made great progress. This slide's a little bit dated, but it gives you the sense that I want to convey of the downward trend in blood lead levels. So this slide shows the percentage of children above the previous benchmark of 10 micrograms per deciliter. So that was the benchmark of indicating what elevated blood lead level is. It was used to, a lot of people designated it as the level of lead poisoning, that and higher. It's a bit of a controversial term. Maybe we'll talk more about that today. But it shows the decline from 1988 through 2002. And importantly, you can see from the figures that there are disparities in lead poisoning. African-American children have the highest exposures over the years. This is still the case, but we still see this downward trend, and we see this reduction in disparities in exposure as well. So if I had another figure that went out until to 2016, you'd still see these declines in blood lead levels, which is great. Early on, and I think Rick, one of our speakers, will talk about this, there were very widespread exposures from lead in gasoline, and once lead was taken out of gasoline, it became more of a concern on lead exposures from housing, soil, dust, and paint. This slide just shows another aspect of our current challenge, and that's the reduction in the level at which children are considered to have elevated blood lead levels. The term poisoning is used sometimes, I believe, inappropriately, but in 2012, CDC changed from the benchmark of 10 micrograms per deciliter that I just mentioned to what we call now a reference value of 5 micrograms per deciliter of lead in the blood of children as an indicator of children that have higher exposures than the rest of the population. It's based on the 97.5th distribution in the in national blood lead levels for children. It's from 4 years of data from the NHANES survey. They're reevaluating 4 more years right now. That's why I have the question mark next to 2016. It's likely that this level will go down from 5 to a lower level. You'll see in the paper recently with Flint, for example, the word lead poisoning is used in reference to the value of 5 and above. It's not really meant to be used that way. It's an indicator of children that have higher levels, relatively higher levels of lead than other children. There's a continuum of effects. There's no level of lead in children's blood where we haven't seen an adverse effect. That's the main reason that EPA went to this reference value. But it makes for a challenging environment for housing programs when you're kind of keying off children with blood lead testing at which level do you intervene. So maybe we can talk a little bit about that in our Q&A. So if you have questions during the seminar, please send them to this this mailbox, leadregulations@hud.gov, and we'll try to get them answered. Give you a second to write that down. Okay, I'd now like to introduce our first speaker, and that is Rick Nevin. Rick is a senior economist with ICF International. He was the principal author of the economic analysis of HUD's 1999 lead-safe housing rule. This is the regulation that governs, that tries to prevent or create lead-safe housing in federally assisted housing, so that's public and other assisted housing. And he contributed to the federal strategy for eliminating childhood lead poisoning. He is also a co-author of several peer-reviewed studies about how lead-safe window replacement can eliminate lead paint hazards, and the author of 3 studies of lead exposure impacts on important societal trends, including changes in IQ, scholastic achievement, and violent crime. Rick? If you could come up here, that would be great.
Thank you. If we can go to the first slide, I'm going to start with a quick overview of known lead exposure impacts. Lead is a neurotoxin, and children are especially vulnerable during the first years of life when the brain is in a critical stage of development. Individual outcomes are going to vary with the severity of lead poisoning and with variations in biological sensitivity, resulting in population impacts that overlap like Venn diagrams. Lower levels of lead exposure are associated with IQ losses, lower education attainment and achievement, and more impulsive and delinquent behavior during adolescence. More severe lead poisoning is associated with larger IQ losses, increased risk of mental retardation, more severe education limitations, and greater risks of violent offending. Now, my research shows how population lead exposure trends have affected national trends in education and behavior. My 2000 study found that lead exposure trends explain most of the variation in the USA homicide rate from 1900 to 1998, and USA violent crime rates from 1960 to 98, and unwed teen pregnancy rates from the 1950s through 1996. My 2007 study showed the same strong relationship between preschool blood lead trends and burglary and robbery rates in the USA, Canada, Britain, Australia, and other nations. And my 2009 study showed that blood lead trends also explain trends in public school prevalence of mental retardation, or MR, from 1948 to 2001. And yes, I know that MR is now called intellectual disability, but I'm going to use the MR term today to be consistent with my earlier study that I'll be citing. We can go to the next one. Now, the time precedence indicator of causation requires that the suspected cause precede the effect. My study findings relate societal trends in lead exposure with best fit time lags that reflect an analysis of a wide array of time lags. The best fit was the 21-year time lag for USA homicides, 23 years for violent crime and robbery trends, 18 years for burglary, and all of these lags, it's important to note, are consistent with lead-induced neurobehavioral damage in the first years of life, affecting peak property crime offending that occurs in the late teens and peak violent crime offending that occurs in the early 20s. The best fit lags for unwed pregnancy were 15 years for girls under age 15, 17 years for ages 15 to 17, 20 years for girls ages 18 and 19, and the best fit for MR prevalence was 12 years for students ages 6 to 18. So again, having tested many different time lags, the best fit was consistently associated with neural impacts in the first year of life. Now, the most common pathway affecting children is lead in house dust. It's ingested via normal hand-to-mouth activity as children learn to crawl, absorbed into the bloodstream, and carried to the developing brain. Heavily leaded circa 1900 paint deteriorated by chalking, causing very severe lead dust hazards, and air lead fallout from leaded gasoline settled as lead in dust. The use of lead in U.S. gasoline fell to near zero in '87, and the USA banned the use of lead paint in 1978, but lead paint in older homes affected many children throughout the leaded gasoline era and is still poisoning children today. We now know that an amount of lead in dust that is invisible to the naked eye is enough to cause neurodevelopmental damage. Now, the strongest indicator for a causal theory is generally accepted to be when it is revealed as a result of an action taken to prevent a suspected cause of disease, and later trends show experimental evidence of cause and effect. In other words, the ultimate test of a causal theory is whether it has predictive power. Does removing the suspected cause have the expected effect in the real world? And that's really what I'm going to be focusing on for the rest of this presentation. My 2000 study tracked USA homicide rates from 1900 to 1998, following the rise and fall of USA per capita use of lead in paint and gasoline with a 21-year time lag. The homicide rate has fallen 52% from 1991 to 2014, but that includes, importantly, a 26% decline from 1998 to 2014. And on this graph, just to be clear, the black diamond trend shows per capita lead use from 1879 to 1987, as reported in my 2000 study. The red triangle trend shows the 1900 to 1998 homicide trend reflected in that analysis, mapped against the lead exposure trends with a 21-year lag. And the green circle trend shows the experimental evidence of ongoing declines in the homicide rate. And I will be using that color scheme repeatedly. My 2000 study also found that lead exposure trends explain 90% of USA violent crime rate variation from 1960 to 98. The violent crime rate has fallen another 36% from 1998 through 2014. The black diamond in this trend shows average preschool blood lead since the 1930s, and the red triangle shows the violent crime rate through 98 with a 23-year time lag following the blood lead trends. The green circle again shows the experimental evidence of ongoing declines in the violent crime rate. Now, the violent crime decline since 1991 has not been as steep as this 1975 to 1985 fall in lead exposure, because the violent crime arrest rate for ages 50 and older has actually increased 24% since 1991. This reflects ongoing crime effects of birth years when lead exposure was still rising. By contrast, the juvenile violent crime arrest rate fell 65% from 1991 to 2014, and the juvenile property crime arrest rate fell by 73% over those years. And we saw the mirror image of this trend in the 1960s when juvenile arrest rates surged, because the youngest age groups are the first to show the effects of both rising and declining population lead exposure. That shift in arrest rates has produced what I think is a very underreported shift in incarceration rates. My 2009 study highlighted this trend using data through 2006, and I'm showing you here that this trend has now continued through 2014. From 2001 to 2014, male incarceration rates fell 62% for ages 18 to 19, 38% for ages 20 to 24, and 27% for ages 25 to 29, but rose 31% for ages 40 to 44 and 82% for ages 45 to 54. Again, we're still seeing the impacts of birth years when lead exposure was rising. My 2000 study added abortion rates by age from AGI with unwed birth rates for the next year to estimate unwed pregnancy rates by year of conception. AGI sent me a letter at the time that study was published that was polite but skeptical about the cause and effect theory. And you can see this quote here. I won't read all of it, but it says that considering societal change regarding marriage, it seems highly unlikely that unwed pregnancy rates will plummet in the next 10 years. Next slide. From 1996 to 2013, the pregnancy rate for girls under age 15 fell by 72%. Next slide. And the age 15 to 17 unwed pregnancy rate fell 66%. The next slide shows that the age 18 to 19 unwed pregnancy rate fell 48%. The decline in unwed teen pregnancy reflects large declines in abortion and unwed birth rates. For women in their 20s, the decline is mostly due to declining abortion rates. Unwed birth rates have increased since the 1990s for women over 25, and abortion rates have increased for women over 40. This is the same shift to older ages seen in the arrest and incarceration rates, reflecting ongoing effects of years when lead exposure was still rising. Now, returning to crime, my 2007 study found that 78% of burglary rate variation through 2002 in Canada, Britain, and Australia was explained by preschool blood lead trends. The burglary rate fell more than 50% from 2002 through 2014 in Britain, tracking the earlier blood lead trends I'd reported. It also fell by more than 50% in Australia. Next slide. And it also fell by more than 50% in Canada. Next slide. In the case of robbery, I found in my 2007 study that 71% to 89% of robbery rate variation through 2002 in the USA, Canada, Britain, and Australia was explained by trends in preschool blood lead. The USA robbery rate has fallen 63% from 1991, including a 30% decline from 2002 through 2014. We can see Canada, their robbery rate fell 50% from 91 through 2014, including a 39% since 2002, 39% decline. And from 2002 to 2014, the robbery rate fell by about 60% in Australia, on the next slide, and also fell by about 60% in Britain. It's just remarkably consistent how accurate the forecasts have been based on earlier blood lead trends. Now, there is an established dose-response relationship between preschool blood lead and IQ later in life. Blood lead of 10 lowers IQ by about 7.5 points. Blood lead of 60 can lower IQ by almost 20 points. And other research clearly links severe lead poisoning with increased risk of MR. Additive exposure to city air lead and severe lead paint hazards in slum housing made severe lead poisoning very common in the 1960s, when public health officials report that there were a large number of comatose and convulsing children with lead poisoning in many inner-city hospitals. A 1982 National Research Council report found that 75 to 80% of all MR students in the 1970s had IQ above 55, and most of these mild cases were of unknown cause, with very high prevalence among children living in urban slums. If we can go to the last slide. My 2009 study showed blood lead trends explain 65% of the variation in MR prevalence from 1948 to 2001, tracking blood lead trends with a 12-year lag. Prevalence in 2012 was 0.87%, the lowest since 1959. Furthermore, you can see that prevalence was 1.2 to 1.3% from 1991 to 2004, but that was when schools switched from the 1974 WISC-R to the 1991 WISC-3, with the latter based on a norm sample of children born as lead exposure was declining. So the bell curve, which is basically the IQ graded on the curve, had less lead exposure for the entire population. Other research has shown that students with mild MR have WISC-3 scores that are about 5.5 points higher than their WISC-R scores. So what this means is that the decline in MR prevalence actually understates the decline in students with severely impaired cognitive ability, because new IQ tests result in higher functioning students being diagnosed with MR. Thank you.
Thank you very much, Rick. It's very, very interesting and insightful data. Do we have any questions for Rick from the audience or any in our mailbox? Okay, you folks who are tuned in via the webcast, don't forget to submit questions through the mailbox. I have one question for you, Rick. Has there been any cost-benefit analysis of preventing lead exposure based on some of the outcomes that you've highlighted, in particular crime?
We really haven't tried to capture the benefits with crime. We still have so much good news ahead of us because blood lead levels have continued to decline. So you'd have to estimate what the crime would be starting about 20 years from now. But Jonathan, I believe, is going to be talking about window replacement strategy earlier. And there has been extensive work that's been peer-reviewed and published showing enormous net benefits from a lead-safe window replacement strategy based just on the impact that lead is known to have on education outcomes and lifetime earnings associated with IQ.
Thank you. And then one other question. I thought I noticed in some of your figures you had preschool blood lead levels averages for U.S. children that went back farther than I thought we had data for. How far back do we have data for preschool blood leads?
What I did with my 2007 study is that in every nation I looked at, I was able to find representative blood lead survey data for at least 1 year, and in some cases for a few. And there have been other studies that I cited that showed that the correlation between lead use in gasoline and preschool blood lead was well above 90%, like 95% during the years that gasoline lead was being used in every country. That wasn't because other risks weren't significant, but for example, the risk of lead paint exposure just changed at a glacially slow rate with changes in the housing stock during the few decades that lead and gasoline was used. So what I was able to do was to extrapolate the blood lead trends based on the combination of blood lead survey data from each country and the per capita lead emissions in each country. And I'm happy to say that there's been another study since then that, at least in the USA, confirmed very well the shape of the curve for the USA blood lead trends based on analysis of tooth lead enamel for individuals born from the 1930s through the 1990s.
Thank you very much. So is it safe to say that all of us on the stage were lead poisoned based on the current reference value of 5, if you use that term?
I think you made a good point earlier. It's difficult to communicate two equally important messages. We still have a serious problem. There's no evidence that a blood lead level of 2 is safe and has 0 impacts, just the opposite. It does have impacts. So at a public health level, this is still an urgent problem and we need to address it as such. But I don't want to scare the living hell out of individual parents who have a child with a blood lead level a little bit above 5, because in the late 1970s, more than 90% of children had blood lead levels above 5.
Thank you. Yeah, it does put it in perspective. Thanks, Rick. Okay, I'd like to now introduce our next speaker, and this is Dr. Pat McLean. Pat has worked with public health programs at the local, state, and national levels for more than 30 years. She is an assistant professor at the University of Maryland School of Nursing and serves as director of the Community Public Health Nursing Specialty, where her research has focused on the issues of childhood lead poisoning and childhood asthma. Pat previously worked for the National Center for Lead Safe Housing, the predecessor to Jonathan's organization, what's called now the National Center for Healthy Housing, during which time she often worked closely with our office here at HUD. Pat currently chairs the Maryland Lead Poisoning Prevention Commission.
Thank you, Peter. And I'm going to talk today about the relationship between lead exposure and education, another outcome of interest certainly to society as well as to parents and people who are working on housing interventions as well. So next slide. So in terms of background, these are very similar to the information that Rick presented. The kinds of effects that we've seen in terms of neurocognitive effects include decreases in IQ. Probably, though, not the outcome we should be most concerned about. Changes in working memory are really key to being able to decode language and learn to read. And it's been suggested that these school performance measures are really among the most meaningful measures, particularly for the society at large. And the grade level test scores, reading readiness in kindergarten, and math and reading scores are really important measures in terms of seeing what will happen with children, making sure children can complete their education, et cetera. In addition to the effects on school performance, we have effects on attentional dysfunction, aggression, delinquency. And as Rick mentioned before, early deficits may persist. And there's no threshold of lead exposure below which we don't get an impact. So no lead level is safe, and we want to reduce exposure as much as possible. So in terms of the association between IQ scores and blood lead levels, this data is very old. These studies go back to 1981, and you can see across different populations the decrease in IQ scores and relationship with increasing blood lead levels. So the higher the blood lead level, the lower the IQ score. And the differences in these curves here are because the population that was being studied was different. Now, this alone, and so we see this loss of IQ, which we think is important, but this alone isn't the full story, because the loss of IQ and losing IQ for a population means that we're really shifting the median of the population IQ, so that we're on the one side cutting off children who might have been geniuses, who have very, very high IQ scores, and on the other side, we're significantly increasing the number of children who have very low IQ scores, would be considered impaired, very low end of normal, who are less able to contribute to society and who need additional services. You've seen this before. Peter Ashley showed this graph showing the decrease over time and the decrease in disparities. What I want you to take a look at is the 1988 to 1991 on the far left side, where the average percentage of African American children in this country, this is US data, 18% of African American children had blood leads over 10. And I want you just to think about that number, because I'm going to present some more recent data to suggest that although the national distribution, the national prevalence of higher blood leads is improving, we still have a really different picture in inner cities in our country. And we need to pay attention to that, because the national picture is not the picture that we see in urban areas. So I'm going to walk through a few studies, and then I'm going to talk to you about a methodology that we use to take a look at educational levels and blood lead levels, which I think might be an important methodology to use in the future for, especially to see what's going on with populations. So this was one of the first studies done in the early 90s, looking at low-level exposure, and you can see with the lowest blood leads being below 5, the difference in IQ. So as the blood lead goes up from 0 to 4.9 up to above 15, we see a drop of about 12 IQ points. And this is one of the first studies that really was able to look at lower lower blood lead levels. Another study using the NHANES data, and this was the NHANES data of 1988 to 1994. This is national population data for the whole United States population. Showed that blood lead levels below 5 had an impact on standardized test results. And you can see here at blood leads, and these were current blood leads. Most of the studies we're looking at look at blood lead in early childhood. But you can see that the lower the current blood lead level, the higher the adjusted test result. So, and our highest blood lead level here is over 3. And we can see a fairly important decrease in the test scores from 95.8 at the lowest blood lead level to 91 for math, and for reading almost 95 to a little above 88. So see very significant differences in test scores. And this is one of the first look at these standardized tests. This study was published in 2007 by Marilyn Miranda and her colleagues studying black and white English-speaking children in North Carolina. And what they found was that the decreases in scores were steeper at the lower level of blood lead. So between blood lead of 1 or 2 and 6, we're losing most of the decline in reading scores. We also found that the decreases in scores were associated with blood leads as low as 2 micrograms per deciliter. This group did another larger study with 58,000 children, finding that lead has a larger effect for children whose end-of-grade reading scores are low. So and that will continue across time, and that blacks had higher blood leads than white, and the effect on score on these reading and math scores were larger for black children than for white children. Now, this study design has been used in many recent studies. I'm going to show you some more results because we know more about the relationship between lead and educational outcomes. We typically use grade cohorts of public school children and the grade level testing that's done at regular intervals. Researchers had looked at city information, county, and state level data. We have different populations being studied in all of these studies. They differ by race, ethnicity, SES, language. Some are urban and at higher risk. So there's a lot of variation in the populations. The blood lead exposure measurements typically done in early childhood at ages 1 and 2, although the state and local requirements differ. Some jurisdictions are testing children every year through age 5. We have a wide difference, though, in the screening penetration rates. The number of children who are actually tested ranges from 10 to 90%. And most of this data is maintained by state-led registries, with all the data being reported by laboratories. The outcome assessments that we're looking at in these educational studies are the standardized tests, reading readiness, reading, and math. And the times when children are typically tested are at the beginning and end of kindergarten, at 3rd grade, 4th grade, and other grades they're tested as well. We typically look at measures that include total scores and whether or not they achieve a benchmark. And in education, if you achieve a benchmark, that might mean that you were ready to go on to 1st grade, or you were ready to advance, or that you stayed behind. So the benchmark is a real important measure. This kind of study gives us a longitudinal look at the effects of blood lead at an early age and the educational effects later on. As you can see, this is from my research, but you can see a child's birth, and then they're tested here at 4 times, 1, 2, 3, and 4 years old, and then they get into school, into kindergarten, and they have tests for kindergarten reading readiness on either side of their school. So we actually end up getting a really good picture longitudinally of what goes on with individual children. And we do this by linking data from school enrollment, which has race, ethnicity, age, language, SES measure, which for us is whether the children are participating in school lunch program. The educational outcome measure, which in my case was the PALS-K measure for reading readiness. And then we have health department blood lead data. And these data are linked into a linked data set, and the identifiers are stripped, the unique identifiers that could identify whether this was a person. They're linked at the individual level, but the identifiers are stripped before the data is analyzed, giving us the opportunity to really look at these unique connections. So it's a very innovative kind of design, and I think something that can be used even in some of the housing studies. And Providence Plan in Rhode Island did the work for me. I know they've been looking at some outcomes for housing as well. So what are the findings? What do we know now? We have findings for blood leads equal to and less than 3, showing decreased end of grade test scores. At level of 4, increased likelihood of learning disability, poor performance on tests. Again, look at the size. We have 57,000 children in North Carolina. We have 35,000 children in Connecticut. When we start looking at 5 micrograms per deciliter, 30% more likely to fail 3rd grade reading and math tests. 48,000 children here in Chicago. More likely to be not proficient in science, math, and reading, 21,000 children in Detroit. And then at the 5 to 9 level, scoring 4.5 points lower on reading readiness, 3,400 children in Rhode Island. When we look at 10 and above, again, scoring here 10 points, 10.1 points lower on reading readiness for 3,400 children in Rhode Island, and between 10 and 19, significantly lower academic performance on more than 3,000 children in Milwaukee. At the higher level, we have a study. This is on the impact of 279 children who had blood leads of 25 and over, levels that we don't see that frequently anymore. This was done in Ohio, finding that these children, these 279 children alone, had a cost of $500,000 per year for special education and juvenile justice costs that's being paid ongoing. So children who are exposed early on carry that exposure and the burden of that exposure on through education. And it's really important that we understand it's not just the time that we test them that we're concerned about, but their whole projection in terms of their life projection. Now, reading and reading readiness are very important measures to our society. If you don't know how to read, you're in big trouble. And 25% of children are entering kindergarten in our country not ready to read. And this readiness predicts a lot of later outcomes. We also know that early educational intervention is more effective, 80% effective if the intervention occurs before 3rd grade, but only 10 to 15% if it's after 5th grade. So this is very important. We also know the costs for repeating a grade or for special ed are 1.5 to 3 times higher than costs we might pay for pre-kindergarten or preschool. Reading is associated with many issues and many factors. These are some of them, but lead is certainly one of them as well. And so it's really important that we understand that all of these factors will affect reading and their students' ability to perform well in school. Now, I wanted to talk a little bit about the findings from our study, and we showed you the 4.5 and the 10.1 points lower on these fall entry scores based on lead levels. But this was almost the same as our findings for what the difference in score were due to our measure of SES, which was a reduced lunch and free lunch. Compared to children who didn't have this category. So children who are coming from poor backgrounds and are lead exposed have this double burden of both of these decreases in score. And again, this is what we found in looking at individual blood lead levels. The highest drop in score was 8 points. It occurred below a blood lead level of 6, indicating that these lower blood lead levels are really the places where we're seeing an effect on children's abilities in school. Now, I talked about the benchmark and the importance of the benchmark. What this shows is that children who had a blood lead of 5 to 9 were 21% more likely to fail that benchmark test when they entered kindergarten. And if they had had a 10 or above, 56% were more likely to fail that benchmark test, which means that they have to have special attention, special programs in kindergarten to hope that they will then be able to pass out of kindergarten. So it's a real burden on a school system to have this big increase in children who need extra educational attention. Now, I mentioned the issue of prevalence and the prevalence of blood leads. And in the study that we did in Rhode Island, the children were in kindergarten between 2004-2005 school year and 2006-2007 school year. So their blood leads were measured in 1999 to 2004, which is that last section on the slide that we saw earlier. The prevalence, however, of blood leads within the kindergarten students in Providence was 20%. 1 in 5 children in the Providence public schools during this period had blood lead over 10, compared to the NHANES data for that period, where it's 1.4% of children in that area. So I think it's a very important finding, and I think we need to really pay attention to the differences that we're seeing across the country, particularly in urban areas. So the lead and education connection is very clear. The findings are very consistent. In addition, children who have lead exposure are not always identified or tracked in school settings. It may be reasonable to share confidential medical information with schools if children are going to be provided with intervention. For instance, if children were provided with access to pre-kindergarten, if they had one of these elevated blood lead levels, and I'm thinking here of 0 to 5, 5 to 9. But if we're not going to do anything about the information, if we're not going to provide them access to services, which would be desirable, then we have a problem where this information could lead to labeling of children within the educational system. So there's much more needs to be done. In fact, we really don't have a good picture of whether the educational needs of lead-poisoned children are being met in schools now. And that is a problem. In terms of what we know about lead and educational programs, we don't have a lot of direct information. But we do know that enriched and nurturing environments and for animals and for humans are very similar. So our knowledge gaps, we don't know which programs work, and we don't know really what kinds of programs would be best. However, let me just skip to the end. Oops. We do know that lead exposure is contributing to disparities, and many disparities. We know there's no safe level. We know these data linkages would really benefit public schools and public health. We need to advocate for resources and approaches that work. And we need to ensure that in the future, all children that have elevated blood lead levels receive the educational services they need. And this is going to set the stage for better outcomes in the future.
Thank you very much, Pat. We have time for a couple of questions. Anybody in our audience? For those on the webcast, we don't have a large audience here. Beautiful day in DC. I think a lot of people are outside enjoying it. Anybody emailing any questions? I have one, Pat, is I guess we lack research on what interventions would be most effective to overcome deficits of lower level lead exposure, but what do we know? I think there's been some animal research on this, and I guess research on children with other deficits, not maybe lead caused by lead.
Yeah, thanks, Peter. Yes, I think we do know quite a bit about other sorts of deficits, and that kind of structured programs. We have data from early education, and clearly early education is making a big difference in outcomes for children. Economic analysis indicate $3 to $7 savings for every dollar that we spend. Then research with children who have autism and developmental disorders have documented significant improvements there. And we know from these other studies that the enriched nurturing environment is really important, both for animals and for humans, and that exposure to books, materials, parents, nurturing relationships, decreased stress, school interventions for poor readers, and the importance of interventions continuing throughout the year across vacations. These are very important findings with regards to education and the kinds of things that will work. We do need to fund studies to look at the extent to which particular programs make a difference. It may very well be that children with lead exposure that they're going to need a more individualized approach in terms of their education. But if we identify kids and then don't provide them with services so they can excel in school, then we're going to have many more problems on the other end. And there's a need for research. There's a need for resources, just in terms of children getting individualized needs met. And I think, for instance, if we were to make sure all these children had preschool programs and access to preschool programs would do a lot to getting them ready for school and moving the dial in that regard.
Thanks very much, Pat. Okay, any question in our mailbox? Nope. Okay, well, let's move on then. Our next speaker today is Jonathan Wilson. Jonathan has worked at the National Center for Healthy Housing for 22 years and currently serves as Director of Research. During his tenure, Jonathan has served as a program manager for research, technical assistance, and policy work. He helped coordinate the evaluation of the HUD Lead Hazard Control Grant Program, the largest and most comprehensive study of lead hazard control in housing ever undertaken in the U.S. He also led research assessing EPA's lead risk assessment protocols and the effects of window and porch interventions on lead exposure. And he has authored over 25 peer-reviewed research manuscripts on lead and other residential health hazards. Jonathan, welcome.
Thank you, Peter. I really appreciate the opportunity to be here today. I'm going to be talking about the home and what we know about addressing hazards in the home. And we need to start with the basic premise. Lead poisoning or elevated lead levels of children are 100% preventable. We took the lead out of the ground, we put it in our homes, we put it in our gasoline, we put it in our communities, and that's why kids are getting sick today. What we need to do is to take it out or to prevent it from children to be exposed from those sources. We can do it. It will take some effort, but we can do it. The problem is not that hard in one level. We know where the lead is in most places, and if we address it properly, then children are going to be safe. It's a part of willpower, it's a part of resources to make this happen. So what is prevention in this case? Looking at this slide, you see data from the national evaluation from 1995 and 1996. And the data being presented is data that controls for housing conditions and looks at blood lead levels of children who are being enrolled into the study. And what we're seeing is on the left-hand side of the screen that we don't know what's really going on with the children before age 9 because we're not testing them at that point. Testing is starting when they're supposed to be going for their 1-year checkups, and some of them get them early. And so in this evaluation, we saw that for a standard home that had a dust lead level on the floors of about 20 micrograms per square foot, that we'd see in this home, a child in this study would have, at that time, with other exposures going on in their life, start off a little bit below 7 micrograms per deciliter as far as their blood lead level, and then would progress up to, on average, over 9 at around age 2, and then would start declining again and leveling off around age 5 or 6. And we see this trend that's also been shown in an EPA study in Milwaukee, showing something similar. And the point of this is that, one, children develop differently or at different stages of development along the way. So at 9 months, my child's daycare center calls it the Toddfint age, where they're not yet toddlers, but they're starting to crawl around, getting exposed to things. And then they're starting to pull themselves up and move and expose themselves to the lead that's on the floor, on the windowsills, and starting to ingest it that way. They're also developing their body. They may be processing more of the lead that's coming into their system. And so we're seeing this increase through the age 2. And then at that point, there's different exposures going on, and it's starting to drop down. Why is this important? When we talk about prevention, if we go after the kid when they have blood lead at a certain level, they may be nearing the top of their point. There will be continued exposure, but we need to stop it early on in this dotted line part of it, or before. We need to be getting into homes and preventing the kids from being exposed in the first place. So how do we do this? We need to understand the sources. There are many sources out there. We've heard a lot about Flint and water. We know that there's sources from parental work or parental hobbies that children may be exposed to. Many other things, including outdoor exposures, whether it's demolition of a property down the street, whether somebody's painting their house and sandblasting it that they shouldn't be doing, whether there's old gasoline, lead that's now sitting in the soil in the park across the street. All these are sources, but what we know from repeated studies is that the number one source is lead-based paint in the home and what happens to that paint as it deteriorates, breaks down, and goes into the dust in the home and into the soil outside the home. Just to set framework here, when we talk about lead-based paint, or when I talk about lead-based paint, we're talking about the federal standard of 1 milligram per centimeter squared. I know that there's certain states that have a different definition, but that's what we're talking about when we present data here. For the floor and sill dust lead levels, we have 2 hazard standards right now that EPA has put out. These are mean levels of 40 and 250 micrograms per square foot. We also have clearance levels. Those are having one sample within a home that's above the 40, the 250, or 400 on window troughs. We don't have a hazard standard for troughs right now. For soil, a play area with 400 parts per million of lead, that's where a child is likely to play, or somewhere in the rest of the yard, 1,200 parts per million. And this is if there's bare area, so something that's exposed to the child. And then we have hearing a lot about it, the water lead, which is at 15 parts per billion. So when we talk about lead-based paint, Rick already presented that blue line that we're seeing, the white lead going into house paint, and how it declined from a peak of around 1915 to coming down to zero at 1978. But what remains is what's in our homes today. And the orange and green lines show data from the American Housing Survey, which was last done in 2005, 2006, and the percentage of homes that have lead-based paint and lead-based paint hazards. So we see in the pre-1940 housing, when most of the lead was going into these homes, we see 85% of the homes have lead-based paint. When we get into the 1940s and 50s, it drops down to 2/3 of our homes have lead-based paint. And then into the 1960s to 1978, 25% of our homes. And that number may be even lower these days. We're looking forward to HUD having another survey in the next couple of years that will take a look at this and see where we are. This is a complex slide, but let me simplify it. I could talk about this for a lot of time, but then we'd have all the people on the webinar drop off, and we can't afford to lose anybody in this room. Let's be honest. This is data from 1940s, pre-1940s. This is from the survey that came before the 2005 survey, and we can see a few trends. One, the blue lines on the right side. This is exterior components within a building, and we see the lines, the percentage of components that have lead-based paint. And so one thing to take away is they're higher than the green lines, what's going on inside the house. So it's more likely we're going to find lead-based paint on the outsides than on the insides. The other thing to look at is the purple numbers. This is the mean lead loadings within these homes. And we can see high levels on windows on the outside and on the inside. It doesn't mean that we should only work on windows, but it does mean that it's a real opportunity point to address these high levels of lead that are on both the exterior and interior of our homes. We see the same trend line if we look at the 1940s, 1960s, or post-1960s. But it's just these bars would get lower and lower with each one of the trends. And how does this translate then to dust? We see that we've got blue and orange in this case, the blue being mean dust lead levels on all floors, and then the orange is floors with a child under age 6. This is interesting data. I'm not exactly sure what it means totally, but what we see is that with the trend with where paint is in the home, we're seeing the dust lead levels mimic that trend. Higher levels in the pre-1940s, and in fact, in the 1940 homes that have children under 6, they're even higher in these homes. So we need to think about that and do something about this problem within our housing stock. This is a complicated slide, but this is really probably the most important one that I'm going to present. And the reason why is this is a simple problem. We need to do something about the lead in our homes, but it's not something that can be a simple answer. It's not something we can say, if we only fix the floor dust, we'll have it solved. It's only if we fix the soil, we'll have it solved. If we just replace the windows, we'll have it solved. None of those individual approaches will solve the problem, because you can see all the arrows that end up at blood lead. We know from our studies that have been done that the most predictive direct source for young children is the floor dust level and is mouthing behaviors. That children are exposed most directly with the floors in their homes. They put their hands on it, they ingest it into their mouths, or get into their mouths, they ingest it, and that's how they are largely exposed. For a segment of children, they have mouthing behavior that may cause them to be interested in going to windows and putting their mouths on them and getting direct ingestion from the windows. But and because of that, we can see in some studies a pathway from window sills to blood lead. But if we're going to solve the problem, we need to stop all these arrows. And so we have to think about what is the solution to this. Talking about windows for a moment, we did a study, and I got to give credit to Peter. He didn't pay me to do this, but just to say that all the studies that I'm talking about in this were actually all funded by HUD and the Office of Healthy Homes. They're the ball game here as far as lead studies, and we need to applaud them for their work. But the study that we had an opportunity to work on looked at the difference between intact and windows. So when we open up and shut windows, there's often rubbing. And the question is, does that abrasion create dust lead? And the answer is, it does in two ways. One is it directly creates dust lead, but the other is that it causes paints to chip, and that then it goes into the dust. When we looked at homes or windows that did not have rubbing or binding or had the paint intact, there was no significant association with the window dust. But when there was a breakdown in that paint because of rubbing or binding or something else, then we see an increase in dust lead levels on the windows, which eventually get to the floors, which eventually get into the children. It's also important to have smooth and cleanable surfaces so we can clean them up easily. And we found that if a sill was neither smooth nor cleanable, that the sill dust lead levels were 63% higher than windows where they had smooth and cleanable surfaces. We talked about the EPA standard of 40, and we've done analyses that show that we really need to be getting at least to 10 on floors and 100 on sills. If we got to that level, we know that less than 5% of children living in these homes would have a blood lead over 10. Right now, with the current standards, the projections are using NHANES data that it's actually closer to 12% that would be exposed, or would have the levels above 10. And that's not even talking about the new reference level. So I tend to talk about 10 as something that we should be aiming for, and 10 that we should be considering the effects of. So this is looking at the effects of certain characteristics of the building on a floor lead level above 10. This is from the American Housing Survey, and they found that if you had deteriorated lead-based paint that's above the de minimis level of HUD, there would be 3% of homes that had this, that in those homes you would be 14 times more likely to have a floor dust level above 10 than if you had a home that did not have any lead-based paint. If you're talking about deteriorated paint anywhere in the home, that's 14% of homes back in 2005, you were 9 times more likely to have a dust lead level above 10 than in a home without lead-based paint. And if you had any lead-based paint, regardless of deterioration, that's 35% of homes, you're 6 times more likely to have a floor dust level above 10. So the first attack is to address the badly deteriorated paint within the home. But on the long haul, we need to get rid of the lead-based paint altogether. That has to be the message. looking at soil lead, and this is not compared to homes without lead-based paint, but comparing soil lead homes to homes without soil lead hazards. There are 4% of homes that had soil lead hazards in the study. They're 4 times more likely to have floor dust lead levels above 10. So what are the solutions? At a minimum, we have to take care of the deteriorated paint. We have to make it all intact. This is not just interior, but exterior. We have to remove the paint from binding surfaces, or at least, right along those surfaces. So we're not creating the hazard that way. We have to create smooth and cleanable surfaces so that once we've solved these problems, we can continue to clean. I'm going to show you a slide on how we can continue to improve the environment once we've attacked the source. We need to use lead-safe practices and use certified contractors in certain situations so that the work is done properly and the dust is properly removed. We should test after work. And we should always consider investing in the next step so that we don't have lead-based paint at all being exposed to children. So a couple more, getting down a little bit further into the weeds, looking at windows, and Rick alluded to this. The question has come up often, what if we really focused on windows? Would it make a big difference? And we had the opportunity to go back 12 years after the original national evaluation of lead in homes and answer that question. And we compared homes that had all windows replaced with those that had non-replacement. And non-replacement was a mixture of things. We didn't dictate what people were doing in their homes. They were doing the best practices among the grantees that participated. And 10% did a little bit of window replacement. 45% did something to the paint on the windows that was significant, such as removing the paint, by stripping, for example, by removing partial sash replacement in some cases, or at least by doing jam liners or trough covers, something to prevent exposure to that paint. 43% did just paint stabilization, making sure that there was no more loose paint, that all the paint was intact. And then 2% actually didn't have to do anything because it was already intact in the first place. This is a lot of data on this slide. This is for the people that like numbers. The next slide is for people that like graphs. And what we see is that if we look at the top line, again, the average level in the study was about 20 micrograms per square foot beforehand on floors. It was on average above 200 at baseline on windowsills. And that for the floors, we see that at clearance we got it down at least in half, and it stayed that way because we stopped the sources, and then people were able to clean and actually continue to get it lower and lower and lower until 12 years later, the levels were below 3. On sills, we do see a jump up. We see an exposure pattern because dust on windowsills is not just from the inside of the house, but it's from being blown in from the outside of the house. And so we see a jump up at 6 months, but then it stabilizes and starts going back down. Again, we've created cleanable surfaces that people can continue to clean, and so that it falls down on average below 50. This shows it graphically, it's smoothed out, and we see a difference between the replacement line, the top line, the bottom line, and the non-replacement line, which is the top line on both of these. So we show that there were significant changes in both groups. We saw that a very successful strategy in both groups. However, with the window replacement group, we see dust levels are 41% lower on floors, 51% lower on sills. Window replacement is a much more effective strategy. We also recognize in the study there were other factors going on that influenced what was going on, including exterior dust, neighborhood point sources, the building condition, especially on the outside, and other side effects that we don't really understand, but we do know that a place like Chicago had higher dust levels than a place like Vermont. And so we need to really consider that as we move forward. There's a lot of information on this, but it's really what I was talking about. It's what Rick was saying, is that there are financial benefits beyond just lead paint. It includes energy efficiency, it includes property value, it improves just keeping kids out of special education in the future. And so both of these strategies are effective, but if we think about it long term, we really should be thinking about how the public and private sector can incentivize folks to do more window replacement to get this problem out of our homes in the long run. I know I'm coming to the end of my time, but I wanted to emphasize a second part, which is in Milwaukee, they had a great program back around 2000 that focused on windows and dealing with windows. And it worked pretty well, but it didn't work as well as they thought. And the manager of that program, Amy Murphy, a real leader in this country on lead, tried to look at it and said, you know what was happening? We told the property owners to deal with the lead on the outside of the property, but we didn't really have the enforcement to make it change. And so porches were supposed to be fixed, but they were not being fixed. Porches are a major source, especially in a lot of northeastern communities where they have these porches. And so we did a study in Rochester and looked at the effects of dust lead up there. We found that on porches, the average dust lead level before work was done was 68. So we're trying to get our floors inside at least below 40, and I would say we should get them below 10, and we've got this source right outside the door that's 68. We've got a problem here because that dust is going to come inside. We know from our studies that the interior floor dust is actually half of the floor dust immediately inside the front door. So dust is coming in from the outside, it's contaminating our houses. So what do we need to do about this? Well, they did a strategy where in most of their properties, they either replaced the flooring, the decking of the porches. It was a highly effective approach. They reduced the dust lead levels by more than half, and it stayed down. It actually declined even further 1 year later. They did some paint stabilization, and that actually did very well. That declined. And it continued to decline, although not significantly from post-work to 1 year. But when they didn't do anything, the dust lead levels went up because the contractors were still working on the inside of the house. And they had no incentive, they had no requirement to test after they were done. And so we see the dust lead levels significantly going up after the work was done. Now, fortunately, just through cleaning and walking and everything else, the dust lead levels did go back down, although they were still higher, although not significantly, than before baseline, but they exist. So what do we need to know? I mean, this is an interesting slide, but it just says where there's significance in these different approaches. So below 10, or above 10, we should be doing something more than nothing. Above a baseline level of 130 micrograms per square foot on the floor, we see a significant difference between replacement and stabilization. But the real take-home message is that porches are an important source. We need to do something because it affects the inside of the house, and we need to think about how we can address this. And the way we do this is we need to set clearance standards. We need to identify a risk standard for porches. We currently know that 40 is feasible, and we can do this effectively by moving forward. And if we do all these things, we can see the curve go down. We can do it beforehand and see that level that we saw early on drop down so we're not getting kids up to 5 in the first place. Thank you so much.
Thank you very much, Jonathan. Do we have any questions from the audience for Jonathan? No? Anything?
We do have a couple.
Oh, we do. Please, Bruce.
Okay, we have a couple of questions from the audience. The first one is pretty much for Rick and Pat. Will there be longitudinal studies which look at the link between elevated lead levels in childhood and cognitive changes, i.e. Alzheimer's, later in life?
I don't have any information on that, but I've often wondered about that what's going to happen when particularly people have been very severely poisoned, not just with Alzheimer's, but with anything related to the brain, strokes later in life, for example, but I'm not aware of research being done on that.
Not my area of expertise, but I believe there have been studies looking at aging effects later in life, and that certainly suggest this. And we do know that very low levels of lead are associated with other adult health effects. So I think this is a big problem and one that we're going to continue to see problems as people age that are associated with these much earlier exposures to lead.
We have a second question. This one is aimed at Pat. Is it likely that a nurse home visiting program, prenatal and postnatal, for low-income households could be cost-effective on the basis of identifying in-home lead hazards and counseling about lead-safe practices?
Well, this is very near and dear to my heart. Actually, there has been a study done in Rhode Island. Mary Jean Brown and I and others were involved in that study. What we found was that we were able to reduce the dust lead loadings in the home. We certainly were able to improve people's knowledge about lead, but we did not show a decrease in blood lead level. That being said, this kind of intervention has not been studied since that time that I'm aware of. I certainly think it would be helpful to parents, but I feel the bottom line is the hazards in the home, and we need to make sure that we're taking steps to address the hazards in the home so that lead hazard control work, lead hazard reduction work are very important. We've also shown that strategies that assist people in moving to safer housing help where that safer housing has lower dust lead levels, and that does result in a decrease in blood lead level. So I think we need to think of things that really change the environment in the home or help people move to a safe home environment. And one other strategy that has been tried with regards to that, although I'm not aware of a scientific evaluation, is looking at the giving people Section 8 vouchers. We have a Section 8 voucher program in Maryland that we've been able to use for families with lead-poisoned children. And this has really resulted in families staying in lead-safe housing for the long term. The problem when you move a child into lead-safe housing is unless they stay in that housing, then they're going to be back in a situation where they'll be further exposed. So we need to find ways to get children into safe housing and keep them in safe housing, particularly during this time period under 6 years of age.
Thank you, Pat. I have one question for Jonathan. If you were king, Jonathan, and you could require us to make changes in our lead hazard control program requirements to our grantees to be more effective, I guess you could say, in reducing lead exposures, what would your new requirements be in a nutshell?
Well, you didn't prep me for that one. You know, I'm going to make a plug for actually your Healthy Homes rating system. I think that sometimes we as organizations get into rhythms that we think we've got the problem solved. We've got a system of whether it's treating windows some way, or we're going to treat soil, or we're not going to treat soil. And the rating system, for those who are not familiar, lists 28, 29 sectors and say that you need to go in and think about each one of these and whether you may have a problem with them. Do you have an electrical issue? Do you have a fall issue from a high window? And it seems to me that some sort of rating system up front that would say, I really did think about whether I'm going to treat soil or not. I'm really going to think about whether I'm going to treat the porches or not. And documenting that to you could be very effective, because I'm not sure, I've heard rumors sometimes that sometimes soil is not addressed as much, that outside of buildings are not always addressed as much. And I think that you're in a position where you don't really know, and if you could have some sort of document that that simplifies sort of the risk assessment report that is supposed to be done in most of these units, that could show you what they're doing, that would be helpful.
Thanks, Jonathan. We do have a new grant management system where the grantees do report on what they've done. So I think we do have the data that would allow us to look at that. But in terms of lead hazards, based on your presentation, it does seem like, and we are working on probably a policy memo to reduce the dust sled clearance standards for our grantees and not wait for that's EPA's purview to create the dust lead standards. And regulatory process is very long, so we're probably going to come up with a guidance that will require our grantees to use the reduced lead dust standards. And I think we shouldn't forget about the porches as well. So thank you. And the final speaker today, hang in there, folks. We're almost done. Is Lisa Christ? Let's wait. Is Lisa Christ from the U.S. Environmental Protection Agency. Lisa is with the EPA's Office of Groundwater and Drinking Water. She's going to talk a little bit about what they do to protect the public from being exposed to lead in water. Thanks, Lisa.
We all advance the slides for me? Okay, great. So thank you very much for inviting me to come talk to you today about the National Primary Drinking Water Rule for Lead and Copper. I'm going to talk a little bit about what the current rule requirements are, spend maybe a moment talking about the challenges that the city of Flint, Michigan is facing with their lead contamination of their drinking water. And then we recently got recommendations from our National Drinking Water Advisory Council on how we can revise the lead and copper rule based on a lot of stakeholder input. So I want to talk a little bit about that with you today. So the lead and copper rule under the Safe Drinking Water Act, EPA is authorized to set public health goals for contaminants in drinking water as well as enforceable standards. So it's important to note that the lead and copper rule is actually a treatment technique rule. So most of our regulations typically have a public health goal and then a maximum level or a standard that a system can't exceed for a particular contaminant. Instead, a treatment technique rule defines a set of actions that a system needs to take to make sure they're reducing lead. They need to minimize lead and copper in the drinking water through a number of different actions. The main one is really reducing the corrosivity of the water itself as it travels through lead-bearing materials, either in premise plumbing or lead service lines. Corrosive water can dissolve that lead, and that's how you get the lead in the drinking water. So one of the key components of the treatment technique is to make sure that the water is minimally corrosive as possible. And then when those actions are not enough, we require that the public water systems actually remove lead service lines. I think Jonathan made a great point. You know, we need to get rid of the sources of lead, and lead service lines is probably one of the biggest sources of lead in drinking water. Okay, so the current rule, as I mentioned, we have a maximum contaminant level goal. So this is the level that we know that there's no anticipated or expected public health effects. And as Pat said, you know, there's no safe level of lead. And so we've set our goal at 0. We then set our action level or our standard at a level that's as close to our goal as feasible. And we need to take into account, you know, how low analytical methods are able to quantify levels in drinking water. And then we also need to look at what are the current tools to reduce that corrosivity, what corrosion control treatment options are available. So we've set an action level rather than an MCL, and our action level is the 15 parts per billion. Now I'd like to emphasize this isn't a health-based number, and this isn't a level that below or above means it's okay or not okay or safe or not safe. It is based on feasibility, and exceeding that action level actually triggers additional things that the system needs to do. An exceedance of the action level isn't a violation, but failure to do the additional actions is. Okay, so next. So the way that a system measures whether or not they've exceeded the action level is they're required to collect samples at customers' taps. and they need to go to the highest risk sites so that they're looking at worst possible cases. Those high-risk sites are those homes that are served with lead service line, or where we know that they have copper piping with lead solder before it was banned in the early 80s. So that's really where they want to target this tap sampling. They collect all their data, and then they look at the 90th percentile tap level. And if that result is greater than our 15 part per billion action level, they're then required to take a number of steps. First thing they want to look at is what kind of quality of water is going through their system. Is it corrosive? What's the pH like? What's the alkalinity like? Do they have a lot of dissolved solids, other factors? So looking at the water quality parameters and figuring out what's best for that system. They do need to install or look at corrosion control treatment, and often that's what's required is to add some kind of inhibitor like orthophosphate. It may be a matter of controlling pH and other factors though. Although lead is typically not found in sources of drinking water, lakes, rivers, that type of thing, we still ask that they take a look, and if lead happens to be in their source water, do treatment to remove it before they're actually bringing it into the distribution system. They're required to conduct public education very shortly after they realize they've had an action level exceedance. This information goes to all customers. It talks about the health effects of lead and then actions they can take to reduce their risk of exposure. Things like flushing their taps before they drink, or perhaps using a filter or other measures. And then finally, as I mentioned, the lead service line replacement is a very important component. The rule requires that systems replace or remove 7% of their lines annually until they have the lead levels back under control. Now, one thing I did want to note as well is when we originally promulgated the lead and copper rule in the early 90s, we required that all large utilities, so those are defined as any drinking water system that serves more than 50,000 persons, all of them had to install corrosion control treatment and maintain optimal water quality parameters. For systems that serve fewer than 50,000 people, if they have action level exceedances, then they're required to install corrosion control treatment. So with that little bit of background on the lead and copper rule, I just wanted to talk a little bit about the challenges that Flint is facing right now and kind of what led to where they are. They were, for many, many years, purchasing treated water from Detroit, and Detroit Water had a corrosion inhibitor that they were adding to it. In April of 2014, an emergency city manager decided that they would move off the Detroit off the Detroit water supply and start using the Flint River as their water supply. That they had no corrosion control treatment in place either to treat that Flint water. So they conducted a couple of rounds of that tap sampling monitoring I described, and although their 90th percentile didn't exceed our action level of 15 parts per billion, the trend was showing that those levels were going up. There were a number of things that were identified as potential issues with the way they collected those samples, which may have underestimated or misrepresented what was really happening with the lead in drinking water. One of the things is they did not conduct all of that tap sampling at those highest risk sites that they're required to, so the ones with lead service lines and other factors. There were some questions about how the results were handled, whether or not proper invalidations of samples took place. And then one of the instructions that they were providing to residents was to do pre-stagnation flushing. And what that means is, under the regulation, we require that the tap samples are collected after the water has sat in premise plumbing and those service lines for 6 hours. We want to make sure we really understand what's leaching out by having that water sitting in those areas where you would typically see lead. They included an instruction to customers telling them to flush, open all their taps, flush the water before they started that stagnation period. And there's been some concern that perhaps that also maybe underestimated the lead that was really coming out at the tap. So other challenges, researchers at the Hurley Medical Center started looking at blood lead levels of children in Genesee County, both before when they were on the Detroit water and then when they made the switch to a new water source, the Flint River. And what they found is the incidence of children with blood lead levels above the CDC reference level of 5 micrograms per deciliter had increased significantly. And I think that really brought the attention of the full federal force at that point. So some of the things that the city and the state are doing to remedy the situation is they are providing bottled water to their citizens. They provided filters, and they've had professional plumbers come in and install filters so that that water is being filtered and they're not getting the lead exposure. And then they are going to replace all of their lead service lines. They're going to go above the 7% annual that's required by the law and just remove those sources of lead. So to help out, EPA established a task force, and it's made up of folks both here at headquarters and within our Region 5 office, which is where Michigan is located. And they're doing a number of things to help the Michigan Department of Environmental Quality and the City of Flint as they move forward. So they provided recommendations on how best to take samples in schools. They provided recommendations on looking at how they're doing this residential tap sampling to make sure they're really getting the most accurate and best possible results from that sampling. Of course, they're doing a lot of work with helping advise them on corrosion control treatment and how to move forward with that. The city is contemplating another switch to a different source of water in a couple more years. And so being prepared, thinking about what they're going to need to be in a good position to control corrosion in that water, as well as what they're using now for a source. Next slide. So I want to talk a little bit about the recommendation, or one in particular we got from our National Drinking Water Advisory Council. So we've been working with them for about 1.5 years with a wide varying group of stakeholders to get input. And, you know, one of their key recommendations was to create a proactive lead service line replacement program. So rather than wait until you have an exceedance and then start ramping up a program, just have it be an ongoing with a goal of removing all the lead service lines. We estimate, based on some research done by the American Water Works Association, that there's about 10 million lead service lines in the United States today. This is some data from the late 80s, and although we know that there's been some lead service line removals, a lot of them have been partials, not full lead service lines. So we're probably still looking at about 10 million lines that need to be removed. And our regulations, we can specify that a water system must remove lead service lines, but for the portion of the line that they don't own, we cannot require that they pay for that portion. They can offer to the customer to coordinate and remove the line at the customer's cost, which has been a contributing factor to why there's so many partial lead service line replacements. Some utilities, however, are not allowed to spend public funds on private land, and sometimes there's access issues to being able to get on a homeowner's property to remove their part of the line. So I just wanted to point out a couple of quotes from the actual report we got from our advisory council. And, you know, one of the things that they acknowledge is that creative financial mechanisms also will be needed to achieve this goal of removing all lines for all individuals potentially exposed to lead, regardless of race, ethnicity, or income. Leaving a lead service line in place because a low-income resident does not have the means to pay raises serious questions of disparate impacts and environmental justice. And then one of their suggestions in the report is that we need some supporting actions over and above what can be done under the Safe Drinking Water Act, and looking to some federal partners to help with this. So some of the next steps, and I thought where this group in particular, and HUD Healthy Homes might be a great partner for us, is thinking about how we can find some funding mechanisms for these low-income folks that want to replace their part of the line but aren't able to. Also thinking a little bit about how we can raise awareness about lead being a source of, drinking water being a source of lead exposure. And when you're thinking about lead paint and other exposures, also thinking about the lead in drinking water as a contributing factor. And then with all of the different Healthy Homes initiatives and things that you're doing, maybe think about how we can not only educate homeowners, but maybe it's part of looking at healthy homes more holistically and lead issues, and considering drinking water and potential lead service lines as a contributing factor. So that's all I had. I guess I can take questions or turn it back over to Peter.
Bruce, do we have one for Lisa?
We do have one for Lisa.
Okay.
The question was, and it had a little comment to begin with the Flint issues, our residents, our area residents are encouraged to test for copper as well as lead. This is for personal information, not the public water supply. It would be good if the EPA would put out their literature for the end user, regardless of supply, to a private homeowner. And then the question is the copper test really recommended? Or is it like part of the lead and copper?
That's a great question, and it is the lead and copper rule. Lead tends to get all of the attention, and particularly in Flint. We do have a standard for copper. Our goal is 1.3 milligrams per liter, and our action level is actually set at the same place. Now, the health effect for copper typically will be nausea, upset stomach. It's not quite as severe as you would expect to see with lead. Folks with Wilson's disease may have more difficulty processing copper. It's probably for most homeowners who are interested in understanding their water quality, it may be something they would be interested in seeing. Typically, if you have a copper problem, you'll have taste and odor issues before you reach that action level. So you usually will know if it's a problem.
Thank you very much, Lisa. I do have one question. So when were the lead service lines used? Or I guess more specifically, when did we stop using lead service lines? I'm expecting they're in the older homes where the residents will be exposed, more likely to be exposed to lead paint and hazards, and then lead and water as well.
I think you got that about right. So it was very commonly used in the post-World War II era. And I think in the 70s, a lot of localities and municipalities quit using it. It wasn't until 1982 that it was actually, 1986 that it was actually banned. The Safe Drinking Water Act was amended, and there was a new definition of what could be considered lead-free. And so 8% at that time was what was considered lead-free. But I think the practice probably was discontinued before the actual ban. But typically we look at older housing stock as where you would expect to see that.
You said post-World War II. What about the older stock, pre-1940?
Probably as well, yeah.
Yeah, okay.
I think it was, yes.
Okay. So just to be clear, our lead hazard control grant funding cannot be used to replace service lines. They certainly can test for lead as under those grants, and they can replace some of the fixtures in the home, for example, but they need to find other sources for the service lines. Anyways, I'd like to thank our speakers today. Sorry that we didn't have a larger in-person audience, but I think we had a good audience viewing the webcast, and we will do better to get an in-person audience, a larger audience in the future. But again, thank you very much for being here, taking the time for your presentations, and it's a very important issue. And we at HUD can look forward to working with you all on the issue. So thanks very much. We have one more question.
There
Bruce?
was one final question. This one was for Rick, and it asks, does the data about the declines in unwed pregnancies correlated with the blood lead levels control for recent increases in use of emergency contraception, such as Plan B?
No, that it doesn't control for that, but we're looking at a trend that goes back from the 1950s. So that, I think, would really be statistical noise in the overall trend relationship.
Okay, that's it. All right, we're wrapping up now. Thank you.